I've been noticing that in my other videos, I go through questions maybe too fast. So I want to make a video a little bit slower, explaining everything with more detail. This whole section, the second half of chapter 8, is all about factoring. And what was the very first method of factoring that we learned? Even before grouping. GCF, right? So for some reason you had like 2x to the 5th minus 4x to the 3rd plus 8. Let's say x. We were able to factor something out, what was in common in all three terms. So what would be in common in all these three terms?
Uncommon? 2.
What's in common?
Oh, in common?
A 2 definitely, and
An X.
an x. Okay, that's the maximum amount of x's that we could pull out. So what would be left? We'd have a x to the 4th, because x times x to the 4th is x to the 5th. And we would also have a negative 2 x to the 2nd. Now how am I getting these terms? I'm thinking 2x times what will give me the negative 4x to the 3rd. So 2 times negative 2 is negative 4. X times x squared is x to the 3rd. And the last term here, what would that be? In other words, 2x times what
4.
will get us the 8x? That would be 4, right? Just 4. And that's it. That is factoring out the GCF. That was the first method that we learned on the second half of chapter 8. And that's always the first method that you should try. Whenever you see the words factor, always try that. Okay? And then after that, we saw quadratic trinomials. We saw factoring by grouping. And then we even learned a shortcut for factoring by grouping when your a value is not 1. I mean, is 1. Like, for example, if I had x squared minus x minus 12, that is a quadratic trinomial. And because there is no number right here, I could set up what my answer is going to look like. Now, the only reason why I'm able to set this up is because x times x is that first term, x squared. Now, if I had a number right here, I wouldn't be able to set this up as x times x, okay? But there is no number. There's like the a value is 1, so I could set it up. X times x is x squared. So now we need to think of, again, the shortcut was what times what is the c value that if you combine together is the b value? Okay, what times what is the c value that if you combine together is a b value? And if you're struggling with this, get a calculator and make a list. Like, how could you get negative 12? Well, that would be a negative 1 times 12. Or maybe a negative 2 times 6. Or maybe a negative 3 times 4. You make a list. Now, which pair of numbers combines together to give you the b value, which in this case is negative 1? So which pair of numbers combines together to give you the b value negative 1? The answer is none of them, right? But at least the negative 3 and the 4, when you combine those, it gives you what? It gives you a positive 1. And your b value is supposed to be a negative 1. So we know we have the right number. We just have the wrong sign. So that negative 3 and positive 4, those are the right numbers, just the wrong signs. So I'm going to change them to a positive 3 times a negative 4. And that's the correct pair of numbers that we're going to be plugging into our answer format. So there's a plus 3 right here and a minus 4 right there. That makes total sense because positive 3 times negative 4 is negative 12. And if I add positive 3 and negative 4, I get negative 1. So that was a shortcut to factoring. And then we also had that long method of factoring. To be honest with you, I would never use the long method of factoring when your a value is 1. But I would use the long method of factoring on something like this. We have 6x squared minus 13x plus 6. Okay? Now, the thing is, you cannot set this up. You can't say x times x is that first term, 6x squared. It doesn't work, right? That 6 is messing everything up. So we cannot set up that shortcut method. So we actually have to use the long method here. So let's go through the steps. Let's explain them, go through them so everybody understands, so we could all get a good grade this Friday on the quiz. Step 1, multiply a times c. And I like to number my steps. Step 1, a times c. And that's obviously going to be, remember, here's a, that's 6. C is 6. B is negative 13. So 6 times 6, that's 36. So that was the answer to step 1. Now, step 2, if you read along right here, it says, think of the multiples of that number, which is 36, that combines together to give you b. So what times what is 36 that if you combine together gives you negative 13? The tip here says make a list. So I'm going to make a list. How could I get 36? And remember, this is step 2 here. So how could I get 36? I could go 1 times 36. I could go 2 times, and if you don't know that 2 times 18 is 36, you could get a calculator and say 36 divided by 2, the answer will be 18. And then you could go 3 times what? That'll be 12. Again, you could use a calculator. 4 times 9. Those are all the possible multiplication problems that give you 36, besides changing the signs. So which pair of numbers combines together to give you the b value, which is negative 13? 4 times 9, right? 4 times 9 is positive 36, and if I combine those together, it does give me 13, but I don't want just 13, I want negative 13. If you look at the b value up here, that's a negative 13. So I have the right numbers, I just have the wrong signs. So I really want a negative 4 times a negative 9. Everybody with me on step 2? Yeah. Okay, step 3, rewrite your b value as those two numbers from step 2. So I want to rewrite the b value of negative 13 as negative 4 and negative 9. After all, negative 4 minus 9, or negative 4 and negative 9, if you combine them, it really does give you a negative 13. Now remember, b does have an x, so I need to put x's on these guys. So step 3 again says rewrite your b as those two numbers from step 2, thus changing your trinomial to a polynomial. In other words, you have originally 3 terms, and you want to change it to 4 terms. So I'm going to rewrite my first term, 6x squared. I'm going to rewrite it down here, 6x squared. Now the b value, that was negative 13x, this guy right here, negative 13x, I want to change that to a negative 4x minus 9x, because negative 4x minus 9x is really negative 13x anyway. And the plus 6 at the very end, I'm just going to bring it down. So we have converted a trinomial to a polynomial. We converted those 3 original terms to 4 terms now. Why would we want to do that? So we could do step 4, which is factoring by grouping. So do I need to make space, or could we just continue from here? Like, this is our first group. The first 2 terms are your first group. This is our second group, okay? So let's look at that first group. What could I pull out of that first group? I could pull out a 2 and an x, okay? So let's pull out a 2 and an x. What would I have left on the inside? In other words, 2x times what gets us 6x squared? 3x. And then how about 2x times what gets us a negative 4x? That's a minus 2, okay? So there's our binomial 3x minus 2. Now let's look at the other group, and let's factor out what we can right here. What could we pull out of there? A positive 3. But if we pull out a negative 3, it'll be even better. Does that make sense? See, if I pull out a positive 3, what am I going to have on the inside? I'm going to have a negative 3x. And we know that we want a positive 3x, not a negative 3x. So what I'm going to do is not factor out just the 3, but I'm going to factor out a negative 3. That way on the inside, I will get a positive 3x, right? Because negative 3 times positive 3x is negative 9x. And then negative 3 times what is positive 6? A negative 2. And as you can see, now we have the same binomial in the first group, same binomial in the second group. So now we could pull out that common binomial. I want to take this blue 3x minus 2 and this blue 3x minus 2 and put it out here in the front. So let me write that. 3x minus 2 out there in the front. What would be left if I pull out the 3x minus 2? Well, I just have this 2x left over. And I just have this negative 3 left over. So there's my factored form. If you wanted to double check and make sure you did it right, you could just distribute, combine like terms, and see if it does give you the original quadratic trinomial up there. Let's try another one. This one, check it out, it's a little different. It says 3x squared plus 30x plus 63. So what should we always try to do first? Always try to do first. Okay, step one, yeah, is a times c. But even before that, like, I mean, think about this, guys. 3 times 63, that's going to be a huge number, right? But look at these three terms. I have a 3x squared, a 30x, and a 63. Is anything sounding a little weird right there? Or anything that you could do? The first type of factoring that you should always try is the first type of factoring that we learned. What was the first type of factoring we learned? GCF, greatest common factor. Can't we pull out something in common from all three terms? Yeah, what is it? A 3. Okay, so let's do that. Let's factor out a 3 from the whole thing. That will give me an x squared, and that will give me a plus 10x, and that will give me a plus 21. What do you think? Yay? Now, check out the beauty part of this. If you look at the inside of your parenthesis, we have a quadratic trinomial. And what could you tell me about this a value in front of x squared? Ignoring this 3, what do you have right here in front? What number's here? Is there a number in front of x squared? There's a 1 right there, right? So do we have to do this long method of factoring? No. Only when you have a number like 3, but right here there's no more 3, you factored it out. So now on the inside, you could actually recognize that you could apply the shortcut. So what times what is 21, that if I combine together is 10. And if you don't know, make a list. So you can say, okay, 1 times 21, 2 doesn't work, 3 times 7, hey, there it is. 3 times 7 is 21. If I add it together, it is 10. So you're going to put a plus 3 right here and a plus 7 right there. And we factored it, but don't forget about this outside 3. That outside 3 still needs to be there. Ladies and gentlemen, that is your factored form answer. You did not have to do the long method. Okay, again, the long method is only when the a value is not 1. The shortcut works when your a value is 1, right? I mean, if anybody had this one, let's say x squared minus x minus 6. Would anybody like to do the long method on this quadratic trinomial? Heck no. I mean, unless you're bored on a Saturday night, right? But right here, you could do the shortcut. What's the answer, guys? What times what is negative 6? That if you add together is negative 1. What times what is negative 6?
3, 2.
Negative 3 times positive 2. And if you add negative 3 and positive 2 together, it does give you the negative 1 in the middle. So the shortcut is great when your a value is not 1. I mean, when your a value is 1. Right here, your a value is 1. Now, always try to do the GCF first, because you might end up with a quadratic trinomial that does have an a value of 1, which means you could apply the shortcut. Okay? Let's take a look at this last one. Could I actually factor out a GCF here? Yes or no? No, I can't. You can't pull out a 2. You can't pull out a 3. You can't even pull out an x. So we're forced to do the long method, right? Okay. What is step 1 on the long method? A times c. And what do we get when I multiply 2 times negative 6? Negative 12. Thank you, self. So negative 12 is the answer to step 1. A times c is negative 12. Step 2, think of the multiples of that number that combine together to give you b. So let me make a list. Negative 1 times 12, negative 2 times 6, negative 3 times 4, and that's about it. Those are the only 3 possibilities besides changing signs that multiply together to give you negative 12. And now we need to find out which of those pairs of numbers combine together to give us the b value, which in this case is positive 3. So if I were to combine negative 1 and 12, what do I get? I get 11. That's not 3, so that can't be it. If I combine negative 3 and 4, what do I get? 1. That's not 3, so that can't use that. If I combine negative 2 and 6, what do I get? I get 4. That's not 3 either. What the heck? What do we do here? We say not factorable. Or we could use the word prime, right? Some books use prime. I like not factorable. Whatever you want. is fine. Not factorial just means that you're not able to factor. And that's it. So hopefully this video gives you better understanding on how to use the long method of factoring. And also, the intentions on this video is for you to recognize that sometimes, or not sometimes, always try to pull out the GCF first, because it might make it a lot easier for you to do. You don't have to use the long method, you could use a shortcut.